Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to understand interval notation and identify the intervals in which a function exists. How are we learning it? Through the intervals and interval notation notes and the intervals and interval notation assignment. When can we use this information? To understand boundaries to determine which possible solutions fall within the boundaries and which do not. How do we know we learned it? By getting a score of 4 on the intervals and interval notation assignment. Now let's take a look at our agenda for today. We will begin by going over our learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll do our weekly raffle. Next, we'll go over the intervals and interval notation notes, and then I'll give you time to complete the intervals and interval notation assignment on Desmos. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your before you go. Your only homework for tonight is to continue working on the reasoning with features of function study guide and any incomplete assignments that you may have. Let's take a look now at the intervals and interval notation notes. The notes begin with the learning goals and success criteria. So what is an interval? An interval is a set of values which satisfy a given function. An interval can be used for any set of numbers, but for most of this unit, it will primarily apply for the domain or the x values of the function. For example, we have y equals mx plus b, which is a linear function, and it's going to go from negative infinity to positive infinity because it goes forever in both directions. So that would be an example of an interval. So interval notation is a way of writing values using the form parentheses a comma b. So where this value here, a, represents the lower boundary, so wherever it stops on the left side, and then b represents wherever it stops on the right side. So interval notation then looks something like this. So we can use parentheses or these brackets. So the brackets are used if that value is included. For instance, if it ends at 3 and it's actually including 3, then we would use a bracket. If 3 is not included, so it gets really close to 3 but never touches it, that's when we'll use the parentheses. So here, if it's less than or equal to or greater than or equal to, we use the brackets. If it's just less than or greater than, we use the parentheses. So it's not included in the set. If it goes on forever, we put infinity, and infinity is not a number, so it can't be included in the set. So it will always be parentheses whenever you see infinity or negative infinity. So if we're given this, x is greater than or equal to 3, and it asks us what is the interval, well, we want all numbers that are bigger than 3. So we know that we're going to have a minimum of 3, and it's included. So we should have a bracket with a 3 here. So that's our a value. That's our minimum. Now our maximum, notice they didn't tell us what the maximum is, so it continues to infinity. So our maximum here would be infinity. So we'd have bracket 3, comma, infinity, parenthesis. So it goes from 3 to infinity, and 3 is included, but infinity is not. Here's another example. It says all integers except negative 2. So notice now we're going to have integers on the left side of negative 2 and integers on the right side of negative 2. So we need all the integers smaller than negative 2. So we know then that negative 2 is the maximum because it's got to be smaller than that. So negative 2 is the maximum, and it's not included because it says except negative 2. So we know we're going to have a parenthesis around negative 2. And the minimum, there is no minimum. We want all the numbers less than it, so that's negative infinity. So this one would go from negative infinity to negative 2. And that's when x is an integer. Okay, we need to state that x is an integer. We need to now include the numbers on the other side of negative 2. So now we want all the integers bigger than negative 2. So we know negative 2 will be the minimum then, and the maximum will be infinity, right, because it goes on forever. So we would have negative 2, comma, infinity, where x is an integer. So both sets apply for this one statement. So it says state the domain of a function with the interval -4, 0. So now we're going to take what we did before, where we had it in words and had to put it into interval notation, and we're going to reverse that. So now we're given the interval, and we need to put it into words. So we know it has a minimum of -4, and -4 is included, and has a maximum of 0, with 0 not included. So we could say that x is between -4 and 0, and includes 4, but not 0. So just putting it into words. So it says, state the domain of the function with the interval -infinity to +infinity with x not equal to 0. So that means it's in all numbers excluding 0. So it has a minimum of -infinity and a maximum of 0. And x has a minimum of 0 and a maximum of infinity. And notice 0 is not included, so we should have parentheses around it. So we could say then that this is all real numbers, all numbers that exist except 0. Now what if we're given a graph and asked to find the domain and range? So domain is the x values and range is the y values. Well, we can see here that this graph goes, and it continues on forever this way, so it goes from -infinity, and notice it gets really close to 3, but it never actually touches it, so its boundary is 3. So we would say then that it has a minimum of -infinity, a maximum of 3, and it's not included, so we would have parentheses -infinity to 3. Now here, our range. Well, we can see that the range, it stops and has a boundary, a lower boundary right here. And we're going to call that maybe -3. If this is -2, this is about -3. So we'll call that about -3. And it goes on to infinity. So the minimum is -3. The maximum is infinity. -3 is not included. Infinity is not included. So it would be -3 comma infinity with parentheses around it.
Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click Start the Activity, and it will take me into the assignment and allow me to begin. So that's how you will log in to Desmos using Google.
Let's take a look now at the intervals and interval notation assignment. The assignment begins with the learning goals and success criteria. If we scroll down, there's a link here to take you to the Desmos activity. Go ahead and click on that link, and it should take you to a page that looks like this. We'll go ahead and click Start the Activity. The activity begins with the learning goals and success criteria. We'll go ahead and click Next. And for each of these, we're going to express the sets in interval notation. So we want all the values bigger than or equal to 3. So we know that we're going to go from 3 as our lower boundary, and it's included, so we're going to use the bracket. So there's 3. And then there's no limit on the other side, so we're going to go to infinity. So if we type the word infinity, INFINITY, it automatically changes it, and we want that to be in parentheses. So that would be our interval for that one. Now let's look at another example. How about this one here? So from -2 to 3, and x is between them. So our lower boundary is going to be -2, and it's included because they have the bar there. So we put the bracket, -2, comma, and then our upper boundary is 3. So we put 3, and it is not included because there is no bar, so we put parentheses. So we'll do that for each of these. Just state the interval of where it exists. Then we'll click Next. Now on the next one, we're going to do the opposite. So on the previous one, we were given an inequality and asked to write it in a interval. This time we're going to be given an interval, and we have to explain in our words what it means. So for instance, -1 comma 4. So we could say x falls between -1 and 4, but does not include -1 or 4. So we would just state what this means. So you'll do that for each of these, and then we'll click Next again. This time we're given functions, the graphs of functions, and we need to state the domain and range. So for A, which is here, we have our graph that goes like this. So our domain here goes from negative infinity, so we'll put negative and then infinity. And then it goes really close to 3 but doesn't actually cross it, so 3, and that's a parenthesis as well. Now our range, well, we could see that it stops here at like -3 maybe. So we'll put this as -3. And then it continues up all the way to infinity. So this is infinity. So that would be our domain and range. So you'll do that for each of the graphs here. Then when you're done, you'll go ahead and go back to your Google form and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.